morning, good morning, good afternoon, good evening, whatever time zone you're in. I hope this finds you in great spirits. And my presentation is on Internet of Things networking layer, device fingerprinting and identification using federated learning. And my name is Anike Sakario. So I hope you enjoy this as much as I did learning about it. So let's dive into it. The first thing I am going to go over is the overview. I'll talk to you about related work, background information in regards to identification and fingerprinting when it comes to devices, problems and formulations with the threats and the models that are used, what approach has or was taken in this research that I've read, the implementation and the evaluation, security, privacy analysis, and conclusion, followed by my timeline, which states the same information except the last part. I'll talk about future work that needs to happen in regards to device identification and device fingerprinting. So I hope you enjoy. Let's go ahead and get started. Related work and background. If you look to your left, there is a chart that talks about work that has been done in the past because it's extremely important to identify the past in comparison to the future to see like where the gaps are and how we can identify what needs to happen or create questions to propose research for future work based on how the world is changing with technology, not how the world is changing with technology. And so in this chart, you have different learning models, which you have machine learning models, you have deep learning models. And so naturally, these different models were used to identify device fingerprinting and identification when it comes to physical hardware and also wireless hardware. We do use it, but wireless local area network, which is a wireless hardware that uses radio waves. Like as a teacher, we'll tell the kids about electromagnetic spectrum and microwaves and radio waves. So there are waves that devices use when they're trying to transmit information to the cloud and also with the central mode in regards to making sure participants and or the client's information is being private. And then we have the hardware network trafficking methods as well. And so when we talk about devices, fingerprinting and identification, what type of model is best used to identify unauthorized or authorized devices, and how can we fingerprint these devices? And so we use traditional learning and deep learning, and more so with traditional learning, it requires like a special set of specific data sets. As far as deep learning, it doesn't necessarily require like a specific data set, but it also has a specific model that it will use to signify if a device needs to have a fingerprint. So this topic is pretty much talking about, I'm going to relate it like to a mall where there's a lot of people. So there's people in the background watching in the cameras to make sure that nothing suspicious is going on. So the same thing happens with devices, whether it's with a smart home, a smart building, a industrial smart environment. There are authorized and unauthorized devices that needs to be identified to make sure like that we're not being hacked. Private information is not being leaked. And so one of the learning modules that's on the rise is Federated Learning Module. And so this is an emerging module because it's been tested to see how can we implement this federated learning module and protect private information that's being transmitted to the cloud without leaking participants and or clients information. And so this is what my topic is about. This is the journal that I found to be interesting because I'm new into computer science and I want to learn more about how it works. And so I usually try to keep it as simple as possible. Even when I was a teacher, I taught physics, so I try to keep it simple as possible. So that's what I'm going to do here too. All right. And so again, there's different modules, and the one that's most emerging now is the federated learning module on how to protect users' private information in a global model, like training module that's going to be used, and also how can it shape the private data in the central mode. Okay, thumbs up if you're good. All right, good job. Let's go to the next one. So this is the actual federated learning module. This is the basic setup of it. And it was created because, well, it was not, it was created for all the other reasons. All the other modules are created to protect privacy information. But also during my reading with the journal, NASA, they were hacked. One of their important missions were hacked because of it wasn't secured enough. And so if you look at this data where we're looking at the cloud, that's where we have all the like the global information that's coming from the different clients that's sitting in the cloud. So that's the first part. That's number one. And then when we look at number two, we have the training, the data set. So that's the data sets that's going into from the cloud to the different clients, and that private information, we want to protect it and then make sure that we get it back to the module on where it's supposed to be, with the information being transmitted from the cloud to the different devices and then back to the central mode to make sure that we are receiving the information and processing the client's information without the data being leaked. So this is the basic federated learning setup on how they want to try to utilize this model to prevent data from being leaked when it's transmitting to the cloud. Just like if you're in the mall, you want to make sure like unauthorized personnel is not going where they shouldn't be, and so that you can actually catch it, identify it, and solve the issue before it actually happens. Okay, yeah, that works. Okay, awesome. Now let's talk about problems, formulation, and threats in models. So one of the biggest problems when it comes to anything technology, Wi-Fi, whether it's hardware, wireless, it's always that chance that there is information that's going to be leaked or is not being transported to the correct network layer with the specific device that it should go to, because we have devices that are spooked. We have hackers that are imitating devices. And so it makes it very difficult when we're talking about Internet of Things and how we want to get privacy with our data or data sets that's being transmitted. But the algorithm is hard to come up with like a precise algorithm in regards to protecting and identifying the different devices and adding fingerprints to those devices. And also another problem is understanding the behavior of the traffic flow when information is being transported throughout different devices with Internet of Things or IoT. And so how do we handle and authenticate what device is supposed to be transmitting what and authorizing that information? So those are two of the largest problems based on what I read that we're dealing with in regards to device fingerprinting and device identification. Now, one of the threat models is communicating to other channels in a secure cloud. So, just like how you tell your friend, oh, I gotta tell you something. Oh, let me tell you this good news, but don't share it just yet. And there's always that chance. It's like, oh, I know they're not going to tell anyone. And then you find out something was said. So it's just like the devices that we use. We want to make sure things are being information and content is being transferred to different devices and the cloud, and our privacy is being kept. However, there's still that chance that something is information or data sets are being leaked. And so the federal not federal, why I keep saying that, federated learning model is intended to create that gap that we need to protect and secure information that's being transmitted from the cloud securely and privately. So the information is being transferred back and forth, and we can also identify and authorize those different devices that are transporting the information in the network layer. And so by doing that, we will identify these devices and then also put a lightweight fingerprint on the device. So we'll, just like us, like humans, we have fingerprints where we can figure out who's who with our fingerprints if it's in a database, just like the Internet of Things. There's the different devices with fingerprints, so you can be able to identify if it is authorized to transmit, receive information based on the fingerprint, but there are some that do not have fingerprints. And so that's the issue that we're dealing with. And the research, the empirical research that was done with federated learning for IoT has actually used that learning model to test how it can, control privacy and data in the clouds. Okay. Now, here we are, the actual architect of the learning model that I spoke about earlier. And so if you take a look here, let's start from our left to our right, left to right. So you have the client at the top, and you have the client at the bottom. So when we look at what's on the top, we see DF right in this circle area here. We see DF, and that is for device fingerprinting. And then at the bottom, we see DI, and that is for device identification. And so when information is being transported to the cloud, we are going to be offline when we are looking at the traffic on how data is flowing. And once we identify that traffic, look at the different patterns, then we'll be able to provide those different devices with a set of fingerprints. We want to do it offline. We don't want to do it online where everybody can see what's going on. That's just like when you're in the mall. Remember I told you about the mall where there's people watching to make sure that nothing suspicious is happening. So we want to make sure it's nice and quiet. Everybody's offline. And same thing here. And so with the identification process for device identification, you're going to be online. You want to see who's authorized to do what. You want to see everybody walking in the mall, just like you want to see all the different devices that's transporting information online. And so that's going to happen online, and implementing like that yellow, you see that yellow cloud in the back, the yellow highlight. That's the federated learning module 4 that's being used to detect the traffic, the new route of, I'm not going to say route, but the new traffic that is taking place from the different devices, and it's recording so that it can capture the data. Okay. All right. So here we are with the identification, the architect of what I just talked about and how it actually looked. So we have the PCA, which is the professional component analysis. And so the professional component analysis, it is there to take in all the, the principal component analysis. It is there to take in all the raw data, meaning the different data sets, and to pass it on to the encoder to see how that information can be broken down, if it's hidden, if it is actually going to transmit or go back to raw data. So this information is being used, to generate, if it can come up with a specific code based on the data that's going in and out from PCA to the encoder, and then it's going to push it through and give it a fingerprint. Once it can identify based on the layers if it's hidden or not, it will be able to give it a code and push it out and then create a fingerprint for that device. So this is the actual architect of what the process would look like. Okay. Now, implementation and evaluation. Implementation and evaluation, there were three different devices. You can see the different names here in the data table on data 2. The three different devices that were used to use federated learning for module to test real data sets to see how well it can prevent private information from being leaked from network to network within the cloud, and also being able to provide a fingerprint. So when we look at data table number 3, there's a comparison between FL4IoT and baseline and centralized learning. If you look at the data from calm down, Nike, from device fingerprinting and device fingerprinting and device identification, the test and the accuracy is 99% when it comes to FL4IoT, and it consistently result with the same number when they're testing data sets on the baseline to see what information is being transferred over to the cloud without the leakage of private private data sets. And then also I just lost my train of thought. But also, so the private data set, but also looking to see the scores between the other 3 experiments that were conducted to make sure that they're able to have the baseline for collecting a fingerprint, and also identifying whether they're authorized or unauthorized devices that are sending and receiving information from the cloud. There we go. Thought completed. Now, here we are with device fingerprinting and identification using federated learning. And looking at the data, it's the same information that was on the chart, but more so in a graph where you can see it visually. And it also talks about the performance of the identification when it comes to the 3 devices that were used, or 3 devices with the module with federated learning. And federated learning had an F1 score of 99%. So that score tells us that this approach is it's feasible to work if it's consistently coming with the number of 99%. So this is approach, a model to use when, again, trying to identify authorized or unauthorized devices, and also giving a fingerprint to those devices that are not identified, and or those that are identified and do not have a fingerprint. Security and private analysis. So some of the security issues is that there's always going to be a problem when it comes to privacy and making sure information is being transmitted to the cloud without it being leaked, just like the incident when it would happen with NASA, where one of their top missions was hacked because the security breach wasn't tight enough. And so, and so there's always going to be issue because the world is drastically, not dramatically, I'm trying to say 2 words in one, drastically changing with machine learning technologies. We're in a digitalized world. And so that will be one of the issues. And how do we prevent attacks from happening? That's another issue. And so with the security and privacy analysis, we are now looking at modules that can help protect confidential information, such as federated learning module that shows a F1 score of 99% accuracy each time that the experiment was conducted with 3 other, and they were able to detect spoof devices. And so that's something we want to implement in regards to sharing confidential information for different devices. But there's still a risk when it comes to data and privacy, trust in the cloud, because it can be compromised. We have people that learn these skills, and again, when it comes to data, right now there's a lawsuit, I believe it's with Hulu and a few other channels for privacy leakage when it comes to data. So this is an ongoing issue. And so machine learning and also the models, yes, not modules, but models of deep learning and federated learning will help us identify protocols that can be used to protect private information that's being transferred to the cloud, and also private information and detecting unauthorized or authorized devices. In conclusion, there's a crucial need for fingerprinting and identification for Internet of all things. Internet of things, but I'll say Internet of all things. Again, this information is so vital. There are so many components when it comes to information on the web, how information is being transferred, how broadcast, I mean, not broadcast, broad bandwidth, the different network layers. So there's so many different protocols and layers when it comes to communication with computers and technology, that there's always going to be a need to identify and fingerprint these different devices and how it's being transmitted and saving, and making sure our information is is placed in confidentiality. And so the protocols, we want to identify like the behaviors of the traffic, and then be able to create fingerprints based on the behavior of the traffic that we've been able to identify when it comes to devices and the different data subsets that's being transmitted. And so the machine learning and deep learning will help us with this information by using the different models that will be issued in a different network systems, so that we'll be able to keep track of what is being transferred in the different layers, or the network layer for Internet of Things. And as we continue to track the information, we have learned that federated learning conducted experiments that result in accuracy of 99% of data being kept private and safe when it was transferred up to the cloud and also back. So that's a high number in regards to accuracy, and it has happened on 3 occasions. And so as we continue to learn about what's next in the future, just know that we will always be exposed to being attacked when it comes to different devices that are unauthorized or may be spoofed, and sharing information across the clouds. So how do we combat this? How do we combat this issue? That's going to increasingly grow, because the world is growing increasingly with technology.